My name is Jacqueline Nguyen, and today we'll be looking at a hypothetical developmental network of spikes in certain cells of the ectoderm of the spiny beetle. However, not all cells in the ectoderm have spikes, some are smooth. The developmental network shows how genes interact with one another to cause things to happen in an organism. So in our normal pathway, the S gene activates the P gene, which activates the I gene, which is necessary to inhibit the K gene. As a result of K being inhibited, the E gene is released from being inhibited, which is necessary to form spikes. What if we have a mutant P that no longer works? Because the P is no longer there, it will no longer activate I, which will no longer inhibit K. Now that K is present in the cell, it will no longer inhibit E, and as a result, the cell won't be able to activate the formation of spikes. What if we have a mutant I that no longer works? When I is no longer there, K will be present because I is no longer there to block it. E will also no longer be inhibited due to the presence of K, and as a result, the formation of spikes will not be activated. What if both I and E no longer work? Because E is at the end of the pathway, the presence of E is necessary to form spikes. So, without the presence of E, we cannot activate the formation of spikes. Lastly, what if both S and K no longer work? The absence of S results in the inactivation of P and I. As a result, nothing is there to inhibit K. However, because we also no longer have the K gene, E will not be blocked and spikes will be able to form still. So, in conclusion, we can see that certain genes are activated or inhibited in cells based on where they are needed. For example, if spikes were to cover the entire beetle, they would get in the way of the beetle's movement and may possibly cause harm to the beetle.